Hi everyone. In today's video, I will be going over the Unit 9 test review. And in this video specifically, I'm only going to go over the first 20 problems. I will make a separate video over problems 21 through 24, which I'll flip over real quick. Those are the word problems on the back, anything to do with 9-6. Alright, so 1 through 20 are basically just log and exponential equations. To be successful at these, you have to be able to tell what type of equation you're looking at, and then from there be able to tell how to solve it based on your given problem. So, number 1, 12 to the 3y minus 4 equals 12 to the y plus 1. So, right off the bat, this is an exponential equation. We have exponents here. These equations can be solved one of two ways. The first way you can do it is by getting the same base, and you solve from there once you have the same base. The other way is by switching the form. Switch form, and since we're in exponential form, that would be switching to log form. Now, depending on the problem, will depend on which way you want to solve it. This problem, we already have the same base. They are both 12. So this would be a problem where you'd want to work with the same base and solve. Switching the form would be quite a bit of work. You would still get the right answer, but I wouldn't find it worth it personally. So since we already have the same base, we can jump right in and cross out those 12s. And then we'll solve what we have left over. 3y minus 4 equals y plus 1. I have two y terms. I'm going to move the smaller one. Minus y on both sides. Y's cancel. And then we got 3y minus, remember this is like a 1y. 2y minus 4 equals 1. 2 steps to solve. Plus 4 on both sides. 4's cancel. 2y equals 5. Divide by 2 on both sides. Y is equal to 5 over 2. And then this would be a problem where you could also use a decimal if you prefer. 5 divided by 2 is just 2.5, so it's nice either way. Number 2 is a very similar type of problem. It's still exponential, as you can see. There's exponents on both sides of the equation. And we have the same base already. It's 2. So we can go ahead and cancel out those 2's and solve our equation. So we have x plus 4 equals 4x plus 13. Two x terms. Once again, I'm going to move the smaller one. Minus x on both sides. 4 equals, again, this is like 4 minus 1, so 3x plus 13. Minus 13 on both sides. 4 minus 13, that's negative 9, equals 3x. Divide by 3. And that's going to give us x equals negative 3. So these next couple are going to up the difficulty level quite a bit. Number 3, we do have an exponential here. Again, there's no log. Now, let's look back at that list above. Our options are find the same base and solve, or switch the form. So you could easily solve this problem using either of those methods. It will be slightly quicker if you opt to switch the form instead of getting the same base, but it's not like that much big of a difference. I am going to switch the form on this one. And then I would like to show both on this problem, but I think it would be better if I showed both options on number 4. 4 is just a slightly easier problem, so I think that's going to be easier to show all around. So for number 3, I'm going to switch the form. It's going to be a faster way to do it. I'll show you both methods so you know how to do it regardless of which method you like for yourself. All right, 8 to the x minus 12 equals 1 over 5/12. This is a good candidate for switching the form because we only have one exponent. So this is currently an exponential form. I want it in log form now. So we have log, and you remember the rule, base stays base, the other two switcheroo. My base is 8, and then the other two are going to switch sides. So we have 1 over 5/12 here, and x minus 12 there. And then we need to put this in our calculator. We'll do change of base formula for that. Remember, it's high over low, and when I say high and low, I mean like how the numbers are written, not the actual value of the numbers. So 1 over 15 is written higher than the 8, so this is high over low. 1 over 5/12 over log of 8. I'll go ahead and bring down the right side, x minus 12. If you haven't already, you will need a calculator for this video, for the study guide. So we have log, should probably turn it on first, log of 1 divided by 5/12. Don't forget parentheses at the end there, divided by log of 8. And this comes out very nice. It's just a -3. One more step to get x by itself. We will move that -12 by adding it. X is equal to 9. So, easy to do if you're just switching the form as well. Number 4, I will show you both ways. I will go ahead and switch the form first since I just showed you how to do that. It's probably still fresh. And then I'll show you how to get the same base if you don't remember how to do that but want to do that instead of switching the form. So, once again, this is exponential. I hope you can see that. And we have our two options. First thing I'm going to do is switch the form to solve it. It's an exponential form right now. I want it in log form if I'm going to switch it. Log, my base is 9, and I'm going to flip the other 2. 243 goes here. 2x minus 6 goes there. Change the base formula to get my answer on the left side. Log, and then it's high over low. 243 over 9. Equals 2x minus 6. And this will still come out nice. Log of 243 divided by log of 9. 2.5. And then I've only got 2 more steps to get my answer. Add 6 to both sides. 8.5 equals 2x divided by 2. X equals 4.25. And I know I'm going to need quite a bit of room for the other method, so I don't want to crowd that space. So this is the switching the form way to do it. Now let's try the other way, same base. If you liked that first explanation and you want to skip this, skip on to number 5, go right ahead. But I do want to show this for those of you who prefer to get the same base instead. So we have 9 to the 2x minus 6. Equals 243. So, to get the same base, you have to break the numbers down. Let's start with the 9. 9 is a quicker number to break down than 243. 9 breaks down into 3 and 3. So that means 9 is the same thing as 3 squared. So I can rewrite the 9 as 3 squared. And then bring down the exponent. Now the 243. We can make a tree out of this if you prefer, but I have a way to kind of get around that. If we're going to get the same base, the numbers have to match, clearly. So we know that the 243 has to equal 3 to the something if it's going to get the same base. So we can go on our calculator and figure that out. So you just test different exponents so you find the right one. I know that 3 squared is 9 and 3 cubed is 27, so let's try 3 to the 4th. 81, we need to go bigger. 3 to the 5th. 243. So my exponent on 243 is 3 to the 5th. 3 to the 5th is the same thing as 243. And there were no extra exponents up here, so that's all I write. Now, of course, if you want to come over here and make your factor tree with 243, be my guest, it's just going to take you a bit longer. Before we are able to drop the bases and solve, we have to take care of those exponents. These exponents, the ones on the left specifically, can be multiplied. 3 to the 2 times 2x minus 6 equals 3 to the 5th. And for that multiplication, you just want to set it up like a distribution problem. Now I can drop the bases and solve for x. In the process, I'm going to go ahead and distribute on the left side. 4x minus 6 equals 5. Add the 6. And then I end up with 4x equals 11. And then divide by 4. X is 11 over 4. And then just a quick check to make sure. I had a feeling I made a mistake, and I just went back and found it. 2 times negative 6, that should have been negative 12 here. Add 12. And then we get 17 over 4. Let's just check to be sure. 17 over 4 is 4.25, which is what I got the first time. So, there we go. Sorry about that error. So 17 over 4, or 4.25, is our answer. All right, number 5. 1/6 to the 3n equals 216 to the 2n plus 5. Now for this problem, again, it's exponential. The list I showed you and the two methods I just showed you on 4, you can use both of them here. I will tell you, if you switch the form on this one, it is going to give you a bit of a headache. It's a bit more difficult with problems that have 2 exponents. It's nice with 1 exponent, but when we have 2, you really don't want to switch the form here. This is a problem where getting the same base is more helpful. So let's do that. 1 over 6. Let's start with that. It's the smaller one. First off, we know that a fraction is the same thing as just having that denominator with an exponent of negative 1. Bring down the 3n. Equals. So again, I'm just going to use that backwards way of getting to my correct base like I did in number 4. So I have a base of 6 on the left. That means my base on the right must also be a 6. And I can't break this 6 down if I want to. I'm just going to demonstrate that real quick. 6 breaks down into 2 and 3, and they are different numbers, so it does not break down. So 6 has to be my base. And I'm going to figure out what the exponent is in just a moment. Bring down the exponent 2n plus 5. Now again, you want the exponent that will turn 6 into 216. So again, start with your base, 6. 6 squared we know is 36. 6 cubed is 216. That's exactly what we're looking for. So this base has an exponent of 3. And then again, before I drop these, I do need to multiply my exponents first. Six to the negative 3n equals 6 to the 3 times 2n plus 5. Bases cancel. Negative 3n equals, distribute, and I'm going to do that a bit more carefully this time. 3 times 2n is 6n, 3 times 5 is 15. 2 steps to solve. First, I'll move the 6n over to the left because the negative 3n is all by itself, so I'm not going to touch it. Negative 3 minus 6, that is negative 9n equals 15. Divide by negative 9 on both sides. And let's go ahead and reduce that. We can divide top and bottom by a 3. So that becomes negative 5/3. All right, so let's move on to a different type. Number 6. I really like these. Log base 1/2 of n equals negative 8. So first, we need to classify, figure out what type this is. This is log equals number. There's a log on one side and no log on the other side, so I just call this a log equals number. What's nice about these problems is they can only be solved one way, and that's by switching the form. Since this is a log form, we want it in exponential form. Base stays base. My base is 1/2. And this time, the base is small in log form. It's big in exponential form. So base stays base. The other two switcheroo. Negative 8 comes over here, and n comes over here. So this is 1/2 to the negative 8th power equals n. And I'm basically done. I just need to put this in my calculator and see what I get. Don't forget those parentheses, 1 divided by 2. To the negative 8. 256. And you can technically check this one. It's not absolutely necessary on this problem, but it doesn't hurt. If I were to plug a 256 in for that log, and again, we're not caring too much about the base, just making sure that the answer itself does work, that we get a number and not a domain error. Right off the bat, we can tell that this is going to work because 256 is a positive number, and logs love positives. But in case you're not sure, you can always quickly pop that into the calculator. And as long as you get an answer, you are good. Number 7, second page. Log base 27 of x equals 2/3. Once again, this here is a log equals number. So we switch the form. This is in log form. We want exponential form. Base stays base. My base is 27. The other two play switcheroo. So we have 27 to the 2/3 equals x. Once again, I'm basically done. I just need to type that into my calculator. 27 to the, don't forget these parentheses, 2 divided by 3. What in the world did I just type? Let me try that again. 27 to the 2 divided by 3. That's better. And then we get 9. 9 equals x. Once again, checking is not necessary on this problem, but if you do want to check, be my guest. We would just plug the 9 back into this x up here, and that's a positive number, so it works. Number 8, log base 2 of 10x minus 28 equals 5. This is another log equals number. So again, we're going to switch the form. Base stays base, my base is a 2. And again, I'm going for the exponential form. The other 2 switcheroo. So this is 2 to the 5th equals 10x minus 28. From here, just algebra. First, 2 to the 5th, that is 32. I'm going to check that just to be sure. Yep. Equals 10x minus 28. From here, I don't have another x term, so I'm going to move the 28 over here with the 32. Adding, we get 60 equals 10x. Divide by 10 on both sides. Sixty divided by 10 is 6. 6 is equal to x. And another reminder, no need to check on this one. I will tell you when we get there. If you want to check, though, be my guest. Number 9, log base 9 of 5x plus 3 equals log base 9 of 2x plus 24. I'm going to split this real quick. We have a log on each side. That's good, and that's called log equals log. When you have log equals log, you only have one option. That is drop the logs and solve. So since I have the same log on both sides, I could just cancel out those logs. And I'm left with 5x plus 3 equals 2x plus 24. And before I forget, this is one of the problem types that requires a check. When you just make logs disappear as if they weren't there in the first place, we can get some numbers that we're not supposed to get as our answers. From here, I've got 2x terms, so I'm going to move the smaller one, minus 2x on both sides. 5x minus 2x, that is 3x, plus 3 is equal to 24. 2 steps to solve, minus 3 on both sides. 3x equals 21. And then lastly, we're going to divide by 3 on both sides. X is 7. Now here's where we definitely need to check. Since we had log equals log, that's the type that can produce a no solution. So I just plugged the 7 back in the logs that have letters, and that is both of them. So I have log, and don't worry about the base, of 5 times 7 plus 3. And again, we have log of 2 times our x, again, was 7, plus 24. Now, once again, you can do the little math in your head and see what number this turns out to be, or at least reason with yourself what the sign is going to turn out to be. Or you can just, as a precaution, put it in your calculator and see. Log of 5 times 7 plus 3. Whoop, wasn't done. We got an answer, so that works for us. And one more time. Log of 2 times 7 plus 24. And we got an answer, so that works for us. All right, number 10. Here we have an equation with 3 different logs in it. We've got 2 on the left and 1 on the right. Remember, you have to have 1 and 1 on each side to be able to solve, and we're not there yet. So we need to get rid of the logs being separated like that. Before we do that, we need to check for exponents. That's the number 1 rule. When we're condensing, that's what I'm about to do. I'm about to condense. And this is the other time when a check is required. If you're condensing, you do have to check. So, first thing we look for are the exponents. Those are the numbers in front of the logs. We've got 2 of them. The 4 and the 3. So from here, we can rewrite. We have log base 6 of x minus log base 6 of, now remember, this is an exponent. This is not multiplication. So this is 2 to the 4th power equals log base 6 of 4 cubed. So make sure you're extra careful with that. A lot of students like to jump in and multiply, and I can see why, but it's still not correct. Before I continue, I am going to go back in and replace the 2 numbers I just got with their actual values. Log base 6 of x minus log base 6 of 2 to the 4th is 16 equals log base 6 of 4 cubed, which is 64. We're still not done condensing. On the left side, we still have 2 logs. We're not supposed to have that. This minus in the middle of them tells me I'm going to divide x by 16 in that order. So that's going to get me log base 6 of x divided by 16 equals log base 6 of 64. From here, I now have the type log equals log. And I've already noted that I have to check this problem anyway because I had to condense. But even more so, since I got log equals log, I will definitely have to check. So there's 2 reasons to check number 10. Okay, once you get log equals log, you can cancel out your logs and just focus on solving the equation. X over 16 equals 64. There's 2 ways to do this. I'll show you one way on this problem. We can cross multiply. If you drop a 1 under that 64, cross multiply. 1 times x is x. 16 times 64, that's 1024. I will show that because it does feel small. I feel like it's still right. 16 times 64. Yep, 1024. And once again, we need to check. That's not bad at all on this problem because if I look at my logs, only one of them has a letter in it. So again, we're just checking log, not log base 6, regular log of our answer, which is 1024. And without a calculator, we can certainly say that it's going to work as an answer. It's the 0 and the negatives in these parentheses that give you a domain error. Clearly, we have a big positive number, so no issues there. X equals 1024 is my answer. All right, next is number 11. Log base 5 of 19x minus log base 5 of x minus 6 equals 2. So, first and foremost, we know we have multiple logs on one side. We can't have that. So this is going to be another condensing one. And when you condense, you have to check. They go hand in hand. So, I'll get back to that later. Condensing. I have 2 logs, no exponents this time, no numbers in front. So I just have to take care of that minus in between the two. And reminder, all that minus tells me to do is divide my 2 terms. So I will divide the 19x by the x minus 6. Log base 5 of 19x divided by x minus 6 is equal to 2. From here, we've got 1 log, so we can describe what type of equation this is. This is log equals number. And if you remember, log equals number, the only way to solve it is to switch the form. This is currently in log form. I need it in exponential form. Base stays base. My base is 5, and it's going to get bigger. So it's a small 5 in log form. In exponential form, it's a big 5. The other 2 are going to switch places. So this becomes 5 squared equals, and then the 19x over x minus 6 is on the right side. From here, I can just solve. 5 squared is 25 equals 19x over x minus 6. Now, a moment ago, I showed you that you can put the 25 over 1 and just cross multiply. That is a way to do it. The other way is to multiply off by the denominator on both sides, which is the same idea as just cross multiplying. I will go ahead and cross multiply again, just because I know that's the general preference, but you can just multiply off the denominator on both sides and still get the answer. 19x equals 25 times x minus 6. Now don't forget you're multiplying 25 by all of this, so it's like distribution. We'll distribute that 25 into there. 19x equals 25x minus 25 times 6, that is 150. And then I'm going to move that 25x over to the left side, since the 19 is by itself. Twenty-fives are going to cancel. And I have just a little bit of space left, so I'm going to come back up here to finish the problem. 19 minus 25, that's negative 6x equals negative 150. And one more step to solve. Divide by negative 6 on both sides. Those will cancel. X equals positive 25. And then don't forget we do need to check this one. When we condense, we do need to check. Condensing can create no solution sometimes. So I need to plug that 25 back into where I have letters. I've got 2 of them. Log of 19 times 25. And log of 25 minus 6. Now again, logs like positives, that's all we're checking for. So 19 times 25, those are both positive, and then we're going to get a very big positive number out of that. So we can pretty easily say that's going to pass the check. And then 25 minus 6 is 19. Log of 19 will also pass. But again, you are more than welcome to still check this if you aren't sure. Log of 19 times 25. Just make sure you get a number. It doesn't matter what the number is, just not a domain error. Log of 25 minus 6. Yep. So we're just checking to make sure we can get a number out of that. So x equals 25 did check out. Number 12. Log of 32x plus 20 minus 19 equals negative 17. No condensing this time, but we don't have the log by itself. And if we're going to solve for the log, it has to be by itself. So let's first move that 19 over to the right side so it's out of the way. I'll add that over. Log of 32x plus 20 equals negative 17 plus 19 is positive 2. Now let's classify. This is log equals number. So, no need to check this one unless you feel like it, but it won't be necessary. Since it's log equals number, there's only one way to solve, and that's by switching the form. Switch form. Right now it's in log form. We need that to be in exponential form if we're going to solve. So, base stays base. The other two switcheroo. My base here, it's not written, so that means it's automatically a 10. It's small in the log form. It is large in the exponential form. And then the other two are going to switch places. So we get 10 squared on the left side and 32x plus 20 on the right. And then from there, it's just algebra. 10 squared is 100. Bring down 32x plus 20. Minus 20 on both sides to solve. $80 equals 32. X. Divide by 32. X equals, we can write this as a decimal or a fraction. If you want to reduce the fraction, remember that handy ABC button can reduce for you. Now this is going to be improper at first, so I'll have to convert it. So see, it's going to give me that. When that happens, remember you just hit second ABC again to convert it to the way you want it to look, which is 5 over 2. There we go, that's better. 5 over 2 if we want to reduce it. And then, of course, we can always just do that as a decimal. 5 divided by 2 is 2.5. So, x equals 5 over 2. Or x equals 2.5. Either answer will do. It just depends on your preference. Once again, if the decimals aren't nice, keep it as a fraction, but this is a nice decimal, so I'll take either. And then reminder, log equals number doesn't cause problems, so you don't have to check it. If we did plug this back in, 2.5, we multiply by 32 and add a 20 to it, it will still be positive, so we're good. Next page. 13. This one is going to take a bit of time. I'm going to go ahead and warn you now. It's not my favorite problem. All right. So we have 2 logs on the left side, not allowed, so we do need to condense. And remember, if we have to condense, we have to check. So if you haven't caught on, you check when you have condensing or log equals log. Those are the 2 times you have to check. Other times they're optional, but you're always free to check if you're ever not sure. So, condensing, we don't have any exponents. Those are the numbers in front of the logs. So we can jump right in and handle the operation, which is a plus. Plus means I multiply the x and the x minus 12. So this becomes log base 4 of x times x minus 12 equals 3. At this point, we can classify. We can see that this is log equals number. And when we have that, we switch. It's in log form right now. I need it to be in exponential form if I'm going to solve it. Base stays base. The other two switcheroo. My base is a 4. And remember, it's big in exponential form. And then the 3 is going to come over here with the 4. And then the x's are going to go to the other side. 4 cubed equals x times x minus 12. And from here, it's just algebra. 4 cubed is 64 equals the x times x minus 12. We distribute that. Be careful here. Reminder, x times x is x squared. It is not 2x. X times negative 12 is negative 12x. And this is why this problem is not the most fun problem to do. We have an x squared and an x term. When we have those in the same problem, there isn't a way to just get rid of either of them. You can't square root, you can't divide off x, those aren't options. At this point, the only thing you can do is move everything to one side, have 0 on the other, and then we'll factor. Since the x squared is already positive on the right side, I'm going to leave it here, and I'll move the 64 over. Minus 64, minus 64. Now be extra careful here. This is 0. We still have something here. X squared minus 12x minus 64. We can't actually subtract anything here because we don't have any like terms. So here we have a trinomial. It's 3 terms, no number in front. That's the best kind. So all we'll need to do is use a simple ACB chart to get our answer, or to get our factors, and then that will give us our answer. Okay, so ACB chart. And 15, I won't need a lot of space, so I'm going to butt into 15 space in just a moment, just an FYI. Okay. A is 1 times C, that's negative 64. B is negative 12. Now we could go through all the factors. 64 has a lot of factors. I'm just going to tell you the 2 that you need. And that's going to be 4 and 16. 4 times 16 is 64. To get negative 64, one of these has to have a negative. I need a negative 12, so that means the bigger number 16 is going to have the same sign. It will be a minus, a negative 16. 4 minus 16 is negative 12, yes. 4 times negative 16 is negative 64. So my factors are x plus 4, x minus 16. Now reminder, these are my factors, so these aren't my answers. To get my answers, remember, we just split and solve. X plus 4 equals 0. X minus 16 equals 0. Minus 4 on both sides, plus 16 on both sides. X is negative 4, and x is 16. So that definitely took longer than our other problems, but still nothing too horrible. We've done our fair share of factoring at this point. Now, don't forget to check. I wrote that note at the top. We've got 2 different logs with letters, so I have to try it in both to make sure it works. So, the negative 4. I have log of negative 4. My first one's just the log of x, so just plug it in, straight in. And I have log of negative 4 minus 12. Calculator. Now, if you already remember the key facts about logs, you're going to know you already know what's about to happen. Log of negative 4 does give us a domain error. It does not pass. Logs hate negatives. So that means negative 4 is not actually an answer. And then it doesn't matter, but the bottom one will also fail. Negative 4 minus 12 will still give us something negative, which obviously will give us domain error. Now reminder, I still have to check the 16. So we're going to plug 16 in just like we did with negative 4. Log of 16 and log of 16 minus 12. Now, once again, log likes positives, so we can already say for a fact that it's going to pass log of 16. If you don't believe me, I'll prove it to you. We just go ahead and delete this. There we go. Liked that. And then log of 16 minus 12. 16 minus 12 is a positive 4, so it'll also work there as well. So we actually just have one correct answer, and that's x equals 16. So this isn't a no solution, but one of the solutions did fail. Okay, let me block off the space I just used. 15 and 16 are very short problems, so it's fine, I wasted that space. Okay, number 14. Log base 2 of 3 plus log base 2 of x plus 1 equals 5. So right off the bat here, we've got 2 logs on one side. That's not allowed, so we do need to condense. And reminder, where you condense, you also check. All right, so we're going to condense on the left side real quick. No numbers in front of the logs, so we just do the operation in between. The plus tells me I'm going to multiply these. 3 times x plus 1. So I have log base 2 of 3 times x plus 1 equals 5. At this point, I can see that this is log equals number. And remember, when you have log equals number, you will switch. That's the only way to solve it. Base stays base, the other two switcheroo. My base is 2, and we're switching to the exponential form since I'm already in log form. So this is going to be a big 2. 5 will go over here. 3 times x plus 1 will go over here. So 2 to the 5th equals 3 times x plus 1. 2 to the 5th, that is 32, equals 3 times x plus 1 will distribute. 3 times x is 3x. 3 times 1 is 3. And then a couple steps to solve. Minus 3 on both sides. 32 minus 3 is 29. Divide by 3 to get our answer. X is equal to 29 over 3. And I'll show you what that is as a decimal. It's not pretty. It could be worse, but it's not a nice decimal. So leave that as the fraction. And then don't forget we had to condense earlier, so we do need to go back and check our answer. So we only have to plug it back into the second log because the first one just had a number, so there's nothing to plug in there. So it's log of x plus 1. So we have log of our x value was 29 thirds plus 1. Now again, as long as there's a positive number in here, we're good. We don't really care what the number is as long as it's not negative or a 0. So if I take 29 over 3, which we can all tell it's positive, it's a decimal, but it's positive. And if I add 1 to it, it's still going to be positive. So this will check out. Now, if you still want to put that in the calculator, be my guest. Just do it carefully. Log of, you'll need extra parentheses for this, 29 divided by 3 plus 1. And I'll close off the parentheses at the end. And you get an answer, so it works. So x equals 29 over 3 for number 14. All right, those were messy problems. 15 and 16 are going to be a breath of fresh air compared to those two. And they are quick. So 15, 2 to the x equals 31. So we don't have any logs. This is exponential form. And we talked about these on the front a while ago. It's been a minute. So you have your two options. You can either get the same base and solve, or you can switch the form. Now, on this problem, you don't have a choice on which one you're going to use. 2x and 31. There is no way we can turn a 31 into 2 to the something. 31 is an odd number. Since that is the case we have to switch form. So same base isn't even going to work here. Which most of you will probably want to switch form anyway here because that's a very quick problem. All right. So it's in exponential form. I want it in log form. And I'm going to bring this down here just because I'm about to run out of space if I try to squeeze it in up here. So again, I want it in log form now if I'm going to switch it. So this is log, base stays base, the other two switcheroo. My base is 2, it's a little 2, and then the other two are going to switch sides. So 31 will go here, and then the x will go over here. And what's so nice about these problems is I switch and I'm basically done. I just need my calculator to tell me what this number is. Remember the change of base formula. Log of it's high over low. And there it's how they're written. It's a position thing. The 31 is written higher than the 2. So that's how I know. And then I can tell you for sure this will be a decimal. So I'm coming over here and preparing to round. Reminder that squiggly equal sign just means I'm rounding. It means I don't have an exact answer. It's just a formality. It's not something to worry about doing on the test or you'll lose credit. Nothing like that. Log of 31 divided by log of 2. And the standard on this test is to round to 4 decimal places. So we go 1, 2, 3, 4. Our fourth number is a 1. The next number after it is a 9. The rule is 5 or bigger, we round up. So clearly we're going to round this up to a 2. So we have 4.9542 as our answer. And what I love especially about exponentials is there's never a need to check. Exponentials can take any number. So that's nice. Okay, number 16, we're going to do another one of those. Let me just write it again so we are focused here. 12 to the 2x plus 1 equals 27. Once again, this is exponential. And same list as I just showed you on number 15. We won't be able to do the same base here. You can try. I'm going to go ahead and tell you it won't work. Plus, this will be a very nice problem to switch and solve. So I'm going to do that anyway, even if I could get the same base. I would still want to switch this one. I like switching if I can do it. It's a little easier. Okay, so we're in exponential form. I need to switch it to log form. Always keep in mind which form you're switching it to so you know how to set up your answer. Log, base stays base, the other two switcheroo. My base is 12. And then the other two are going to switch sides. Log base 12 of 27 equals 2x plus 1. Now that didn't give me the answer straight away like 15 did, but it made the problem easier for sure. So my calculator is going to tell me what this is. I'm not going to write out the change of base formula this time just because I'm running a bit low on space here. So it's log and then it's high over low. So the higher number, the number it's written higher is the 27. Divided by log of low, the number written lower, the base, 12. And we're going to have to round here. So 4 decimal places again. 1, 2, 3, 4. We're at a 3. The next number is a 4. The rule is 5 or bigger. So since 4 is just a little too small, this will stay a 3. So we have 1.3263 equals 2x plus 1. And then we solve. Minus 1 on both sides. And when we subtract the 1, it's just going to remove the 1 at the front. So this will just become 0.3263. Feel free to use your calculator if you're not sure about that. Equals 2x. Divide by 2 on both sides. I will definitely need my calculator to get the final answer. and it will be a decimal for sure. 0.3263 divided by 2. And end up with 5 numbers, so I'm going to round again at the end. This 5 is big enough to bump my 1 up to a 2. So this is 0.1632 for my final answer on 16. All right, thank you for bearing with 16 equation problems. 17 through 20 are going to be so quick. We've already discussed how to do these in some of the equations. Hopefully those equations we had done enough where you're kind of picking up on a lot of the patterns that I've been talking about, and so you'll be definitely quicker by the time you get to test day. Evaluate each logarithmic expression. Show work by using change of base formula or like bases. We actually didn't talk about that, so don't even worry about it. Change of base formula. Basically put this in the calculator and get an answer. Now remember, on they're supposed to be very easy problems, very easy to get points for them. But you have to show your work if you want the points. I want to make sure that you actually know how to get the answer. So remember, it's log, and then I write high over low. That's how I like to explain it, if you will. The number that's written higher over the number that's written lower. You'll see that in all 3 of the problems. So number 17 is log of 1 over 16 over log of 2. If you want credit, you have to write this out. Not this. This is just my formula, if you will. But this work, you do need to show it. Calculator. Log of 1 over 16, close that parenthesis, divided by log of 2. Negative 4. Again, log high over low, 5 over 125. Log of 5 divided by log of 125. And that's not going to be pretty. So you can either do 4 decimal places. That would be 4 threes, 0.1, 2, 3, 4. Now, hopefully some of you recognize this. This is actually a very common fraction. So let me change that. Second PRB to flip between fraction and decimal on this calculator. That F to D button means fraction to decimal. It will convert to the other one. So I will make this another option, or 1/3. Now most of you I know will probably go with the decimal because that's what the calculator gives you right off the bat. That's fine. But 1/3 is what I would personally put. I'm more of a fraction person. All right, one more. Log over log, and it's high over low, 32 over 4. Log of 32 divided by log of 4. And that one's much nicer. It is just 2.5. All right, so last but not least, number 20. Number 20 just kind of reiterates what we were just doing on those last 3 problems. Express log base 31 of 3 using change of base formula. So basically what you would type into the calculator like we just did. So I'm just going to write it out. Log over log, and again it's high over low, 3 over 31. So now you just look for the one that looks like what I just wrote here. And it looks like it's going to be C. And remember, another way to remember this is the base number always goes on the bottom as well. Okay, that was the first 20 problems. I'm going to stop the video here and I will make a second video over the back page. That one will be not nearly as long as this video, but I did want to make 2 separate videos for this study guide. I hope that this helped. If you have any questions, outside of the video, feel free to contact me via email or come see me in person. Otherwise, I hope you have an awesome day. Bye!